Hey guys, today we're going to start our journey through geometry, and we're going to start off with some basic geometrical principles, mainly working with perimeter and circumference and then area. So perimeter and circumference are similar because they're both the measure of the outside of a shape. Perimeter works with polygons and is the sum of the measures of a polygon's side lengths. And so in the lower left-hand corner, I have a rhombus with measures of, side length measures of 6 and 5 and 6 and 5. And so to get the perimeter for that, I add up 6 and 5 and 6 and 5 and get 22 inches in this case. Circumference, on the right-hand side, is the distance around a curved object. Okay, so we're going to find the distance going around the circle. And for that, we're going to use a formula, which is 2 times the radius times pi, or if we have a diameter, it would just be diameter times pi. And for pi, we're going to use 3.14. So for this example, we had a radius of 10 yards. So we take 10, multiply that by 2, and multiply that by 3.14, and we'd end up with a circumference of 62.8 yards. So from our measures on the outside, we're going to look at measures on the inside. We're going to talk about area. And so we'll start off with the area of a rectangle, and the formula for area of a rectangle is length times height. You could also see it as base times height or length times width. So in this case, we have a rectangle with a side length of 4 and a side length of 2. And we would take those two measures of 4 meters and 2 meters, multiply them together, and get 8 meters squared. Now, we are dealing with 2 dimensions here, so that's why the meters become squared, and we now have the area of what is inside the boundary of the rectangle. So from the rectangle, we'll look at a special rectangle called a square. And the square is going to use the same basic formula, length times width, or we could say side squared, or side times side. So in my example here, I have a square with a measure of 6 meters by 6 meters. We can take 6, multiply that by 6, get 36. And again, since area is a 2-dimensional measure, that is meters squared. Next shape is a rhombus, and with the rhombus, again, we're going to use length times height, and sometimes with the rhombus, we might not have a nice easy side length, so what we have to do is drop what's called a height, okay, down from one of the vertexes perpendicular to one of its opposing side lengths. So in this case, I have a side length of 6 and a height of 5, and so we multiply those together, and we get 30 meters squared. All right, and then from there, we'll look at everyone's favorite, the trapezoid. The trapezoid tends to give people a little bit of issue because it's got a different formula to use than the other 3 that we've seen so far. So with the trapezoid, the formula we use is we take both of the bases. In this case, I've got a base of 7 and a base of 12. And we add those together and then divide them by 2. And then multiply that by the height. Again, the height is a line that is dropped down from one of the interior angled vertexes down to one of its opposite side length. So in this case here, as I said, I've got a measure of 7 and a measure of 12. Those are my 2 bases, so I add those together, and then I multiply that by half or divide that by 2. And I get 9.5, and then I multiply that by the length of the height, which which is 8, and I get 76 feet squared as the measure of the area for this trapezoid. Okay, so from there, we'll move on to a triangle. And a triangle has a formula that is 1/2 the base times the height, or 1/2 times the length times the height. Okay? So in this example, I've got a height of 12 mystery units. Okay? There's no units given, we'll just say it's U. And I've got a base of 16 units. So I would multiply 1/2 times 12 and get 6. And then multiply 6 times 16 and get 96. So again, since area is a two-dimensional measure, the measure would be 96 units squared. All right, so from our polygons, we'll look at a circle. Sure, something we're pretty familiar with. The formula here is we're going to use that pi again, and this time we're going to use the radius and multiply it by the radius again. So we're going to use pi r squared, or pi times r times r. And again, we're going to use 3.14 for pi. And in this example, I have a radius of 5. And don't forget, if you have a diameter length, you have to cut the diameter in half. So my initial setup would be pi times 5 times 5, or then pi times 25, and then 3.14 times 25. And since, again, we had meters, and area is a two-dimensional measure, this would be meters squared, so the answer to this would be 78.5 meters squared. And that's it for the measures of basic area. Now we're going to look at a couple of things like combined measures, such as inscribed shapes. And on an inscribed shape, there is one shape that is on top of the other. Okay? So in this case, I've got a square lying underneath and a circle on top of it. And for this example, we're asked to find the area of the shaded region. So what we need to do is find the difference in the areas. So I have a radius of 10. And if you look at the circle touches the very edges of the square. So we can therefore say that since the radius of the circle is 10, the entire diameter would be 20. And that would end up being the measure of the side length of the square. So we would take 20 and multiply that by 20, because a square has the same measure on each side. And that would be 400 units squared. Then if we look at the circle, again we're going to use pi times the radius, or pi times 10 times 10, or pi times 100. And we would end up with 314 units squared. So now that we have 400 units squared from the square, and 314 units from the circle, we would subtract the two areas to find the difference. So 400 minus 314 would leave me with 86 units squared. So 86 would be the region that is shaded in this case. And so our last little bit is to look at a composite shape. And a composite shape has multiple different shapes in one. And in this case, I've got half a circle and a rectangle. And so the easiest thing to do with these is to find what two shapes the composite shape is actually made of. And again, this time it is half a circle and a rectangle. And find the area of those specific shapes. So with the rectangle, I have one side length of 24 units and one side length of 6 units. So I would take 24, multiply that by 6, and get 144 units squared. So then if we look at the circle, well, I've got half the measure of that side length on the rectangle is 12, so then that would leave the diameter of the circle to be 12. So I take 3.14 and I multiply that by 6 and by 6 again. Now don't forget, with the circle measure we need only the radius, so that would be half the diameter. So 3.14 times 6 squared, or 6 times 6, leaves me with 113.4 units squared. And so now that I know the measure of my rectangle and I know the measure of my circle, I could put those together. But what I need to do first, since I only have half a circle, is take that 113.04 and divide that by 2, because I've only got a semicircle. And that will leave me with 56.52 units squared. So now I can take my 144 units squared and 56.52 units squared, put those together, and come up with 200.52 units squared, and that would be the measure of the area of that composite shape. Okay, that is it for this. We will be practicing this in class, and we'll see you then. Ossa!